Hey everybody, just wanted to make one more video for you because I realized that I did not put any problems quite like this into the class notes. And so you have a number of problems where you need to come up with what the function should look like given a graph of a secant or a cosecant or a tangent function. And so I want to do one example for you like that. So we take a look here at what we've got, and the first thing right off the bat that I want us to remember is what is the general shape of our secant and cosecant graphs. So remember that secant generally looks like this. And then we've got vertical asymptotes. And then cosecant looks very similar to this, except it has a vertical asymptote at 0. And so it has this kind of look. And remember, you can always remind yourself of why they have this shape by remembering that the secant is 1 over the cosine, and the cosecant is 1 over the sine. So anywhere there was a 0 for sine, cosecant's going to have a vertical asymptote there. And anywhere cosine had a 0, secant is going to have a vertical asymptote there. All right, so as I look at this, I suppose either one could work, right? Because we can always shift things left and right. But as I look at the picture of my cosecant, it sure seems like that would be the better choice here because of the fact that we seem to have this exact same pattern, right? Vertical asymptote at 0, then we start with this positive piece of the graph. All right, so we're going to go ahead and put in here cosecant. Okay. Now, let's think about what's happening in terms of y values. Right now, normally this is at 1 and this is at -1. So you kind of think of this x-axis as kind of the home base, and then up 1 and down 1 to get the graph started. All right, so that's clearly not happening here. We're not just going up 1 and down 1. So we're going from -4 is where these local max values are, and then 2 is where these local min values are. So we have this distance of 6 here. So if I have this distance of 6, then half of that is where we're going to kind of have what was our x-axis. So I know that instead of me kind of working off my x-axis, what I want to actually be working off of is this -1, right? So halfway between this point and this point. And so what that means is that everything has been shifted down 1. Let's put a little -1 there. But also, I haven't only gone up 1 from that line and down 1 from that line. I've gone up 3 and down 3. So that means that there's a vertical stretch. So I can go ahead and put a 3 out front there. All right, so now let's think about what's the period of this thing. So I can look here and it looks like 1 full cycle has happened after 5, right? Because right after 5, it sure looks like there's a vertical asymptote at 5, and then I start back up here again just like I did right on this side of 0. So I'm going to say my period is 5. And of course, what I know is that b is going to be 2 pi divided by my period. So I can go ahead and put 2 pi over 5, and that is going to produce this. Notice that cosecant, this has the same pattern as cosecant does, so there's no horizontal shifting needed at all. So I can just go ahead and put in 2 pi over 5 times x. And that will produce this graph for me.